everyone, welcome back to my channel. Brianna Dignard here. Today I am going to be just chilling with you guys, building this Jane Goodall LEGO set that I've had for a number of years at this point, and answering some of your science questions. So I put out a request on my Instagram and my YouTube page asking for your science questions or just any questions about me. So we're gonna do that. Let's open up this box. This is only 276 pieces, so I feel confident in my ability to complete this LEGO set. Step 1, build Jane Goodall and assemble her army of chimpanzees. Jane Goodall's ready. She's gonna watch me as I answer your science questions. Oh, PC. Oh, PC. That's not a LEGO piece. That's a nail. I actually don't know where that went. I hope it wasn't important. First question I got asked, or the first one I'm going to answer in this video is, how can the Hubble telescope take pictures of the universe that it resides in? I will put a disclaimer, I may not have fully understood what the question was asking me, but the Hubble telescope, which was put into space by NASA, doesn't take pictures of the universe as a whole. It takes pictures of parts of the universe. It's very similar to like if when you go outside and take pictures on the Earth, you're taking pictures of the Earth, but you can't get a picture of the whole Earth because you're not in outer space. So the Hubble telescope does that. It takes pictures of part of the universe, but it can't actually take a picture of the entire universe because the Hubble telescope is only orbiting like 320 miles above Earth's surface, just outside of Earth's atmosphere. So it's not outside of our universe, so it can't take pictures of the universe. And the reason it gets a better picture quality than something you could take from a telescope from here on Earth is that Earth's atmosphere is not very nice to trying to take pictures because it blocks a lot of incoming electromagnetic radiation or even different wavelengths of light, which is nice for us because it helps protect us from like, a lot of UV light or other things, but not so nice for taking pictures. So the Hubble telescope, even though it's not that much closer to objects in space than we are on the surface of the Earth in the grand scheme of things, because it doesn't have to take a picture through the Earth's atmosphere, it gets a lot clearer of a picture. So that was the first question. Again, apologies if I didn't answer it correctly, but it's not really taking pictures of the universe as a whole because it does live in the universe. It's taking pictures of part of the universe. Let's build some LEGO. Okay, the base platform. Time to answer another question. Next question I got was, do your body chemicals change as you use a certain perfume? So it is kind of well reported, and I think generally or like colloquially known that your perfume will smell different on you versus another person due to your body chemistry. So things such as like the type of skin you have, like oily, dry, combination, sensitive, your skin's pH, how often you sweat, how hot your skin is, and stuff like that will all have an impact on your perfume because it can change how long your perfume lasts, how much like their perfume is giving off, even bringing out subtle different notes in perfume. So your body chemistry can affect your perfume you're wearing. I couldn't find a lot of information about whether or not wearing the same perfume over years and years and years would actually alter your body chemistry. I don't know if anybody has like truly looked into that, and also like body chemistry and all of these different interactions are very complicated science. So I like barely scratched the research of it, like the surface of it with my research. I think the closest thing I found that could potentially answer this question is that over periods of times your bodies can develop allergies to certain things. So there is the potential that if you use the same perfume for years and years and years, you might end up developing an allergy to it as your body becomes more sensitive to it. And your body changing how sensitive it is to something could be an indication that its chemistry is changing as well. I don't know if it's changing as a direct result of that particular perfume or as a result of something else, because things like hormonal shifts or illnesses can cause allergies to develop as well. So that was the closest I could find the answer to your question. is that perfumes could change your body chemistry in the way that you might end up developing an allergy to something you didn't have an allergy before, but there wasn't like a direct, like, couldn't find direct research on that. But yeah, so like perfumes and body chemistry and their interaction is actually very interesting. Like I said, very complicated science, because like figuring out like all these different factors, and then you have to figure out what goes into like what controls your skin pH, what controls like the type of skin you have, how do those things affect the perfume. It's all like a lot of science. It's a lot of cool stuff. Like cosmetics and perfumeries and stuff like that are very heavily driven by science and chemical research. So there you go. Let's build some more Lego. I think I get to put down the green part. This is like the platform and then greenery. So yay, Lego. Got some of the green space covered, which is appropriate for our next question about what makes evergreen plants bear leaves perennially. So this is kind of like a fancy planty way of saying, why do evergreen trees stay green all year round? Or evergreen plants, because there are plenty of plants that are not pine trees that are evergreen. So I did address this in a previous video, so for a long answer, I will direct you to my prior video on this. The short answer to this question is it comes down to leaf growing strategy. So it takes a lot of energy for plants to grow leaves. And of course, the point of those leaves is to do photosynthesis and create energy for the plant. So if it takes more energy to grow the leaf than the leaf can make in a season, they're not really gonna grow that leaf. It doesn't make sense energetically for them. This is why deciduous plants lose their leaves during the fall and then don't have them during the winter, because when it gets so cold, the leaves would be most likely to freeze, unable to undergo photosynthesis, and wouldn't be able to make any more energy for the plant. So instead of wasting energy keeping the leaves around that aren't doing their jobs, they just cut them free. Leaves aren't doing their job anymore. Goodbye. Evergreen plant leaves have special adaptations that allow them to survive colder temperatures. So, for example, like pine needles and the needle-like leaves help conserve water. Many of them contain special kind of like natural antifreezes in them that prevent freezing, and they can even be, they're often waxier than deciduous tree leaves because, again, for the same reason, trying to save water, not freeze, and therefore they can photosynthesize all year round. Eventually, though, leaves will fall off of evergreen plants because the leaf just gets old and it's time for it to die. Not because it's dropping its leaves each year, but just because the life cycle of that leaf is up. So that's the short answer. Again, go check out my previous video on evergreen plants for the longer answer. And then I will answer one question that was more about me. So it was, what qualities are you looking for in a friend? And honestly, I've made most of my friends through shared hobbies. So like I've talked to people and been like, yeah, I sew and knit and crochet and do science. And they'll be like, oh my gosh, I sew too. Or oh my gosh, I do science too. And then we usually just like talk for like instantly and then become friends. I'm not a very social person, so without the ability to find some sort of like hobby to connect with, I'm pretty bad at making friends. Wanting to hang out with me is a huge plus. I like the desire to actually want to spend time with me. That's a good quality to have in a friend. I think just in general, I like to be friends with people who have a kind of the same spark or passion for things that I do. Not necessarily having passion or a spark for the exact same things, but just like having a topic that they could talk for hours on end about, and just like listening to them talk about it, and then like I get to do the same thing in return. That's the gist, I think, of what I look for in a friend. Somebody who's nice, somebody who wants to hang out with me, and somebody who gets excited about things too. Cool, questions answered. Lego it up. My Jane Goodall Lego set's all done. Look at the Jane Goodall and the little chimpanzees. This is fun. I have 2 more questions to finish answering, and they're both about me. So one of them is, let me get this. Which video was the hardest for me to do research-wise thus far? I would say probably the film photography videos have been the hardest to research because I was never that great at reduction oxidation chemistry in school, and film photography chemistry is all like reduction oxidation chemistry, so it's hard to like keep it all straight in my head. And also because there's just not a lot of people publishing information about the science of film photography in like really hardcore chemistry terms. You get a lot of stuff about like from the photography community from a more artistic creative side of view versus like hardcore chemistry, but those were also just fun videos to make, and I enjoyed trying to find that information. So those are probably some of the hardest ones to research. Also, the ones on people that not a lot of information exists about them. Wish more information existed about some really cool people. And then final one, what is your favorite piece of lab equipment? Love to hear more about your lab experiences, what you were studying, what you learned, etc. I don't actually know what my favorite piece of lab equipment would be. I have a lot that I have some love-hate relationship with. Weirdly enough, I did enjoy my mouth pipette, which is like considered super taboo in the scientific field. Again, I used this in my sea star research lab, so all I was doing was using a mouth pipette to like move sea star larvae from one place to another place. We never used any chemicals in that lab. We didn't even use soap on our glassware or it would kill the larvae. So not super, the biggest thing I was at risk was eating a sea star larvae. That was just fun because it's like a weird skill to have. There's also something in my graduate lab where I studied atmospheric aerosols called the SMPS, which is scanning mobility particle sensor, something like that. And I didn't really like it, but I had to take the entire thing apart in our lab and try to put it back together again to get it to work. And so thus I kind of developed a love-hate relationship with it, like it was my child because I had taken it all the way apart, but I also hated it because it never worked. So those might be kind of my two at the top of my brain. This is gonna be it for today's video, but I do plan on having a live stream next Friday in place of my normal weekly posting, just for, well, I've got a lot of things going on. And I've been meaning to do a live stream, so weirdly enough, doing a live stream actually is less work. But anyhow, so I'll be happy to talk more about my past lab experiences in that live stream next Friday, and I'll be posting more information about that throughout the platforms of the socialness. So again, this was my little Jane Goodall LEGO set that it was fun to build. I've been kind of having a rough past couple of days, so I really just wanted to sit down, do something a little bit fun, answer some of your guys' science questions because I love getting to connect to you guys in that way. Hope you enjoyed it. Hope you got your questions answered, and as always, keep it sciencey.